We have chlorine to be 17,287. We have argon, which is 18, to be 288. We have potassium, 19. Now, the M shell can only contain 8 electrons, hence the extra electron will move on to the next shell, which is N shell. We have 2881. And lastly, we have the number 20th element, which is calcium, to be 2882. So with this, I believe we now understand how electronic configuration work and how the atomic structure of an element is positioned, drawn, and I believe we understand that. Now, we understand that the arrangement of electron into shells of an atom is referred to as electronic configuration. How is the electronic configuration significant to the position of an element in the periodic table? Now, the position of an element with electronic configuration. So for this, we should understand that the number of notations in the electronic configuration will show the number of shells of electron the atom has, showing the period. The last notation shows the number of outer electrons the atom has, showing the group. What do I mean by that? Now, if we were to draw the shell of sodium and chlorine, for example. So for sodium, we have the nucleus, we have the first shell containing 2. We have the second shell containing sodium, it has atomic number 11, containing 8 here. And we have the last shell containing 1. Now, from this, the electronic configuration of sodium being 281. These are what I refer to as notation. Now, the number of notations here, 1, 2, 3. Number of notation. Gives us the period of this particular element. And the last notation here gives us the group. So if we're to take a look at this, obviously the group of sodium is group 1, while its period is period 3. Now, simply put, we should understand that since sodium is 281, indicates that sodium has 3 shells in its atomic structure. The number of shells an atom has gives the period in the periodic table. Why the valence electron the number of outermost electron give us the group of the element in the periodic table. So let us take chlorine as an example again. Chlorine is an element that has the atomic number 17. And for that, its atomic structure, we have 1, 2, 3, 4, 5, 6, 7, 8. And lastly, we have 1, 2, 3, 4, 5, 6, 7. Hence, it has electronic configuration of 287. And because of this, the number of shell is 3, hence the period of chlorine is period 3, while the group is number of valence electron, which is group 7. Now, I believe that is clearly understood. Now, the periodic table, like we said earlier, is a table which contains elements. And it doesn't just contain elements, it also demonstrates or it gives us information about the properties of the element. When I mean properties, we should understand that the periodic table consists of elements that are metals and non-metals. Metals and non-metals. Now, we can deduce the property of an element by classifying the element as a metal or a non-metal. When I say property, I'm talking about its acid-base character, its electrical conductivity, either it is positive, electropositive or electronegative. All these properties, we can deduce it by knowing if the element is a metal or a non-metal. Now, what are the characteristic properties of metals and non-metals? So I would like us to take a table so we can use that to discuss. So the property that we're dealing with, I'm just going to adjust this. So the first property we're going to look at is electronic configuration. Now, for metals, the electronic configuration is very simple. Metals are found to have 1 to 3 outermost electrons. Metals belong to group 1, group 2, and group 3 in the periodic table. And if you remember so well, since metals are found to have 1 to 3 electrons in the outermost shell, hence they can belong to group 1, 2, and 3. Non-metals are found to have 4 to 7 electrons in the outermost shell. Another point to understand is the bonding. Now, the bonding that exists in metal is metallic bonding due to the loss of the outer electron. So metals have metallic bonding because they are electropositive. And non-metals are electronegative, hence they have covalent bonding. Another property that is important is the electrical conductivity. Now, talking about the electrical conductivity, metals are known to be good conductors, while non-metals are simply poor conductors. Also, we have other properties such as types of oxide form. Metals are known to form basic oxides. A few of them are amphoteric, while non-metals usually form acidic oxide, and some of them are neutral. Now, talking about the reaction with acid, most metals react with acid. Why non-metals do not react with acid. Talking about physical properties, metals are known to be malleable. They can be bent. Metals are known to have high melting point and boiling point. They are known to be ductile. They can be drawn into wire. While non-metals are flaky, they are brittle, and they have low melting point and boiling point. Now, that being said, I believe that we can now take past paper on what we've done so that we before we move on our short video to complete the periodic table. So let us tweet past question on everything we've done. So right here from multiple choice precisely, our first question states that which one of the following names does not correspond to a group of elements on the periodic table? To as alkali metals. Group 2 elements are referred to as alkali earth metals. Group 3 to 4 are metalloids, while 4 to 7, 5 to 7 are non-metals. Halogens are group 7 elements, refers to the word salt formers. Group 6 are non-metals. Alloys is a name that does not correspond to a group of elements in the periodic table. So our answer is C. Question number 2 says, group 8 elements are known as noble gases. What name is given in group 2? Like I said earlier, group 2 elements are referred to as alkaline earth metals. And that is simply because they react with water to form alkaline solution, and they are not decomposed by fire. So our answer is C. Group 3 elements. Question number 3, rather. Which class of elements are useful for making semiconductors? Which class of elements are useful for making semiconductors? Semiconductors are group 4 elements. They are the metalloid. They are elements known to possess the attribute of metals and non-metals. They are being used to make semiconductors. So group 4 element, they are the semi-metal element. Answer option D. Question number 4 says, which row describes how elements are positioned on the periodic table and the names used? Now, like we mentioned earlier, elements are placed in the periodic table by their atomic number. The group refers to the vertical column, while the period refers to horizontal row. Hence, option A is correct. Question number 5 states that the early periodic table was used to classify the known element and was used to predict the properties of the element that have not yet been discovered. Which will correctly describe how this was possible? Now, elements in the same period are arranged based on their similar physical properties. So the unknown elements were used to fill the gaps in the original periodic table, even though they were not known yet, but due to their physical nature, they were placed in the periodic table for further research. So our option is option D. Question number 6 states, potassium and krypton are elements in period 4. It is easy to deduce that from the number of shell present in both,